You know, in our digital world, pretty much everything is locked. Your bank account, your private messages, heck, the entire internet, and every single lock has a key, a cryptographic key. But think about it. If that key is just a file sitting on a computer, how safe can it really be? Where do you possibly put a key that can't ever be copied or stolen?
Well, the answer isn't just to hide the key better with more software tricks. The real answer is to build it a fortress. Not a fortress of stone and mortar, but one made of silicon and steel. And that's the core idea we're going to dive into today. So here's the plan. First, we'll look at why software keys are so darn vulnerable. Then we'll introduce our digital fortress, take a peek inside its walls, understand its almost unbreakable security, and finally, see how we guard the guards themselves.
All right, let's start with the heart of the problem, the vulnerable digital key. This is exactly where most security strategies can and do fall short.
Now, you might be thinking, hey, my key's encrypted, it's safe. But if it exists as a file on a computer's hard drive, it's basically living in a really dangerous neighborhood. A virus, a hacker, even a compromised operating system, they can all find ways to snatch it. Think of it like leaving your house key under the doormat. Yeah, it's hidden, but it's still way too easy to find.
And this right here is the fundamental difference. On a regular computer, that key is just another file, totally exposed to all the system's weaknesses. But inside what's called a hardware security module, or HSM, the key is generated inside a secure piece of hardware, and it never leaves. It's physically isolated from all the chaos of the outside world.
That whole concept of physical isolation brings us straight to our star of the show, our digital fortress, the hardware security module.
So what exactly is an HSM? Just think of it as a dedicated little computer whose only job, its entire reason for existing, is to be a paranoid, ultra-secure vault. It doesn't browse the web. It doesn't run spreadsheets. It generates keys, stores keys, and uses keys, all from within its own hardened, protected shell. This is the bedrock security that protects things like credit card transactions, the software updates on your phone, and the certificate authorities that make the entire internet tick. And these fortresses, they actually come in all shapes and sizes. They can be as small as a USB stick, a card you plug right into a server, a standalone box that sits on your network, or even a service you can rent in the cloud. But the principle is always the same. A hardened, dedicated environment just for your keys. Okay, so how does this fortress actually work its magic? Let's go inside the walls and see how it keeps those keys so incredibly secure. The whole process is actually pretty elegant. The main computer just says, hey, HSM, I need a new key. The HSM then uses its own super high-quality random number generator to create one completely internally. And here's the critical part. That brand new key is immediately stored in the HSM's own encrypted memory. It never ever, not for a millisecond, touches the computer's file system. And this is the real magic trick. When you actually need to use that key, say to digitally sign a document, you don't pull the key out of the fortress. No way. You send the document into the fortress. The HSM does all the signing work inside its secure walls, and then sends the signed document back out. The secret key never has to see the light of day.
Now that process is really secure, but what makes the fortress itself practically unbreakable? Well, it all comes down to multiple layers of both physical and digital protection.
First up, let's talk digital defenses. The keys aren't just sitting there. They're wrapped in multiple layers of encryption, even inside the HSM itself. And to even talk to the HSM, you can't just type in a simple password. You need strong authentication, often something physical, like a smart card or a special token. You have to prove you have the right to even knock on the door. Then you've got the physical defenses. Now there's tamper evidence, which means you can tell someone tried to get in, kind of like a broken security seal on a bottle of medicine. But tamper resistance is a whole other level. It means the device is actively built to stop you from getting in at all, with things like reinforced cases and specialized hardware. But what if a really determined attacker just ignores all of that? What if they literally take a drill to the case and try to physically get to the chips inside? What is the HSM's final last-ditch line of defense? The answer? Zero. A big, fat zero. The very moment an HSM detects a physical breach, a change in temperature, voltage, or even the pressure from a drill bit, it triggers its ultimate defense. It instantly and permanently erases every single key it holds. This is called zeroization. The attacker is left holding nothing but a very expensive, very useless box of electronics. Your secrets simply vanish, completely safe from their hands.
An unbreakable fortress is amazing, but you also need to be able to trust its day-to-day operations. And that brings us to our final section, guarding the guards. This is all about trust and accountability. You can securely back up the keys, but they stay encrypted and often require another HSM or a special smart card to restore them. These devices are built to meet really strict government and industry standards, like FIPS. And every single action, everything that happens, is recorded in a secure log, giving you a perfect audit trail of who did what and when.
So when you boil it all down, it comes back to this one powerful idea. By creating this secure hardware bubble for our most sensitive keys, we dramatically, fundamentally reduce the risk of them ever being compromised. So I'll leave you with this question. As our world relies more and more on digital trust, the security of these keys becomes absolutely everything. So think about it. Are the keys to your digital kingdom being kept in a flimsy software shoebox, or are they protected inside a real fortress? Thanks for tuning in.